put it in YouTube format. Okay. Now there's two forms. There's standard form, which is of the form f of x is equal to a times x minus h squared plus k.
Mm-hmm.
And if you have it in that form, then your vertex would automatically be hk. Although it doesn't ask for it, your axis symmetry will be x is equal to h. And your min, or your max, is equal to your k.
Okay.
Now, it's a min if your graph opens up.
Yeah.
So if a is greater than 0, then your graph's going to open up. And if it's a max if your graph opens down, which is a is less than 0.
Okay.
Now you also have a form called general form. And this is where you got f of x is equal to ax squared plus bx plus c. And for here, your vertex would be negative b over 2a. That all of the 2a should be in the denominator.
Mm-hmm.
And f of negative b over 2a.
Yeah, that's what kind of threw me, Professor, the f of negative b over 2a.
Yeah.
So just you solve for negative b over 2a and then you plug it into the formula?
Right.
Okay.
Then the axis symmetry will be x is equal to negative b over 2a. And then your min, which is still, if your a is greater than 0, it's positive. It opens up, so there's a min. Or your max, where your a is less than 0. And this is going to occur at f of negative b over 2a. So those are the forms we're going to be working with. Now the vertex formula, that's what it's referred to in the general form. The steps to it, our first step is to identify A and B. You don't actually need C. Then step 2, plug these values, substitute these values, let me put that in there. Substitute these values into negative b over 2a and simplify. Then substitute the value from step 2 into the original function and simplify. Now this value here in step 2 is the x part of the vertex. And this part is the y part of the vertex.
Yeah.
Now, number 5. We have f of x is equal to 2x squared minus 4x minus 1. And the graph comes later on. But it first asks us to find the x and y intercepts of each graph, if any exist. Now how you find the x-intercept, you always plug 0 for the other variable. So to find the x-intercept, we plug 0 in for y. And remember, y is the same as f of x. So we got 0 is equal to 2x squared minus 4x minus 1.
And we solve it.
Right. And it won't factor, so we'll use quadratic formula.
Oh, I see.
So a is 2, whatever number's in front of your x squared. B is whatever number's in front of your x, which is negative 4. And C is your number at the end, which is negative 1. And remember, your quadratic formula is x equals negative b plus or minus square root of b squared minus 4ac all over 2a.
Is that delta?
Not. Oh, what I wrote?
Yeah, the square root of b to the power of 2 minus 4a. That's delta,
Oh,
right?
c
Oh, yes.
minus 4ac.
That's delta, right?
I'm not used to hearing it referred to that way.
Yeah.
But those just correspond to our letters there.
Okay.
Now, if you mess up on signs, it's best to go through and replace all of your variables with parentheses before you plug in your numbers. Now, everything else remains exactly the same. We're just going through and we're going to plug in our values now.
Okay.
Now, b is negative 4, so everywhere I had a b, I'll put in a negative 4. A is 2, so everywhere I had an a, I'll put in a 2. And c is negative 1.
Okay.
Now, negative negative gives us a positive 4, plus or minus. Negative 4 squared is 16. Negative 4 times 2 is negative 8. Times the negative 1 gives us a positive 8 over 4. Then we got 4 plus or minus square root of 24 over 4. And you always simplify your radicals in 8 point. In this case, we got square root of 24. And the prime factorization of that, we got 2, 4, 8 times 3. Now we're looking for pairs of something when we're dealing with square roots. Here's a pair of 2s, so the pair of 2 is going to come out in front as a single 2.
Oh.
Now we're left with a 2 times 3 inside, which gives us 6 over 4.
And then we can remove the 2.
Right, exactly. Because if you can divide this number, and this number by the same number, do so. And they're all divisible by 2. Now for graphing purposes, this is not very useful.
Yeah.
It's actually easier to write them in decimal form. If I split this up, what that plus or minus means is we got 2 plus square root of 6 over 2, and we got 2 minus the square root of 6 over 2. Anytime you got more than a single number, you're going to put it in your calculator, you have to put parentheses around it. So when we plug this in, we'll put parentheses on top on both of these. So I got beginning parentheses and then 2 plus the square root, so I do second x squared. In your calculator, I'm sure it'll be different. And then close parentheses, divide by 2. And that gives us, I don't know, 2.2. Probably you'd have to be a really good graphing by hand to get anything more precise in one decimal place. Get that. Then the other one is 2 minus, oops, gotta have the parentheses on it. 2 minus, and then the square root of 6. Divide by 2. And that gives us a negative 0.2. So I'll come back to those. Those were our x-intercepts. Okay, now our y-intercept. You always I'm sorry.
We plug the x equals to 0, right?
Right. You always plug the other variable in, so we'll plug it, like you say, that x equals 0. Now remember, f of x is the same as y, so this says y is equal to 2 times 0 squared minus 4 times 0
Minus 1.
minus 1. And so then that gives us negative 1. And probably not a whole lot of use to put this in the point form. If that's the only thing they're asking for on tests, then it would be. But if you're going to use that for graphing purposes, you just y-intercept of negative 1 knows it crosses at negative 1 on your y-axis.
Okay.
Now, then it says if it's in general form, convert to standard form, or vice versa. Now this one's a little bit tricky to put in standard form. In general, to go from, this is called general form. When you're talking about quadratics, to go from general form to standard form, step one, you want to factor out the GCF of the first two terms. Now this is assuming that it's in a ax squared plus bx plus c form. So for this one right here, we've got our y is equal to 2x squared minus 4x minus 1. Then, actually I shouldn't say the GCF, because it may not always be that way. Factor out the coefficient.
It's to the power of 2, right?
Correct. Coefficient of the x squared from the first two terms. Now most of the time that's going to be a GCF, but I can see a problem where it might not work that way. So the coefficient on the x squared is a 2, so I'll factor out a 2. Now notice I do not touch the last term at all, the constant term. I only did it from the first two terms. And I'm writing this in terms of x's, but you can have it in any variable. Take the number before the x, the coefficient, multiply it by 1/2, square it, and then both add it and subtract it inside the parentheses. So take the number before the x. The number before x is a -2, and usually you do this over an aside, part of it anyway. Multiply by 1/2. It's always times 1/2, and it's always squared. So -2 times 1/2 is -1, and -1 squared is a +1. And then I say, and both add it and subtract it inside the parentheses. So we're going to have y is equal to 2 times x squared minus 2x plus 1 minus 1.
Yeah. Minus 1. Okay.
Now, that seems weird.
Yeah.
But,
no, it's factorable, right?
Yeah, exactly. This is going to be considered our first group, and then this will be our second group. So then, like you say, you're going to multiply sort of. So multiply by the number out in front by the different groups, by the two groups. Now that may seem kind of strange, multiply sort of. Are you going to multiply or not? Well, what I mean by that is using the distributive property, we're going to take this 2 here and we'll multiply it times our first group and times our second group.
Okay.
So we'll have 2 times x squared minus 2x plus 1, and we'll have 2 times -1, and then this -1 will carry down. Is that good so far?
Yeah, I get it now.
Okay. And then you're going to factor what is inside the parentheses and perform math operations to simplify the numbers. So this now factors as x minus 1 squared, and 2 times -1 is -2 minus 1 gives us -3.
Okay.
And now that's in standard form.
Right.
Now if it's in standard form,
The vertex is easy.
Right.
Yeah, vertex is easy. Yeah. Nice HK.
Yeah, so then your vertex, you got your H and K. And remember, H is always opposite sign on this. So this says -1, so our vertex will be 1, and then -3.
Okay.
Now, axis symmetry will be x is equal to 1, and we'll talk about that here shortly. And A is the number that's in front, so A is 2, which means it's opening up, which means we'll have a min. So our min, and your min is equal to the k, which is -3. Okay. Now let's take a look at the graph. Our vertex is 1, -3, which is right here. And your vertex is the lowest point or highest point. Since this is opening up, it'll be our lowest point. Our x-intercept is 2.2, which roughly be there, and -0.2, which roughly be there. And your axis symmetry is x equals 1. That's an invisible line. It always passes through your vertex. And really, after you have your intercepts here, our y-intercept was probably -1. After you have those, knowing that there's a curve to it, then you can sketch it. And by symmetry, if you flip this over, that'll give you the other part of the graph. I'm not very good graphing by hand, but I think you get the idea. Does that make sense on that one?
Yeah.
Yep, got it.
Was there any other parts on that particular one that was, domain and range? Well, the domain, when you're talking about quadratics, at this point, is always -infinity, +infinity.
Right. The range is negative, the minimum, I guess, or...
Right. Whatever you came up with for your min, whether it opens up or down then, in this case it opens up, so you'll go from -3 to +infinity.
Okay. Professor,
Yes.
is that the line that runs not parallel to the min? If you drew like a line parallel to the x-axis at the min, is that like a derivative kind of almost of the function?
No, it's if I were to draw a line here, like this right here, you going on to calculus?
I took it like many years ago, so this is
Okay.
all.
What this is your slope is equal to 0.
Mm.
And if you remember calculus, when you find a derivative and you set it equal to 0 and you solve it and you find your critical values, you're right. This is the point where it changes. Your graph changes from increasing, decreasing, or vice versa, and that gives you your relative min and relative maxes.
Okay, all right. Sorry.
Oh no. Do you have any other questions on that one?
No, I get it now. I get it.
Okay, I'll go ahead and erase that, and then I'll show the next one. Unfortunately, I have to do an undo, so it takes a little bit to erase.
Mm.
Okay, so let's see, number 6. I'm glad I revised that because this one doesn't have a GCF. -3x squared plus 4x minus 7. And then do you want to see all the parts again, or do you just want to see the putting in the standard form, or?
Yeah, it's standard form. Yes, please.
Okay. Yes, to see all the parts, or just the standard form part?
Just really the standard form, and maybe I guess I understand the quadratic equation So I don't really, I can get that by myself for finding x-intercepts.
Okay. Well, to put this into standard form, our first step is to factor out coefficient of the x squared from the first two terms. So
-3.
exactly. Now going backwards, if you think what factor means to divide out. So this one would be 4 over -3
Right.
with an x, of course. So this is -3 times x squared minus 4/3 x minus 7. Then take the number before the x, multiply by half and square it. So we'll take the -4/3, multiply it times a half and squared. It gives us -4 over 6 squared, -2/3 squared, or 4/9. Now let me double check my basic math. Okay. And then we not only add it, both add it and subtract it inside the parentheses. So this will be plus 4/9 minus 4/9, and then the -7 carries down here. And we're grouping these three together, and we're grouping the last one. So then multiply sort of by the number out in front by the two groups. So this number that's out in front, and sometimes there is no number there, but you're going to multiply it times your first group, and you multiply it times your second group. Except we don't really multiply it through. In this case, we just put it out in front. So this is -3 times x squared minus 4/3 x plus 4/9. And then we'll have a -3 times -4/9 minus 7. Now step 4, factor what is inside the parentheses. This is very easy to factor. It's x minus 2/3 squared. And this is plus 12 over 9 minus 7. Now why I say it's simple to factor is whatever number's right here, right before you square it, is always what goes right here, sign included. So there really is no factoring.
Oh, wow. Okay.
So if you remember that trick, it makes the factoring on all those real easy. So then we got -3 times x minus 2/3 squared. And this simplifies top and bottom both divided by 3. So it gives us 4/3 minus 7 equals -3 x minus 2/3 squared.
21 minus 4.
Yeah, so I was trying to think what that is. It's a long day. -17?
Yeah.
Okay. Yeah, this is a mixed number form. You take -7 times 3 is -21, and then you add the 4, and it gives you a -17 over 3. And now it's in your standard form. So you can plot. What?
And that's 2/3 and minus 17 over 3 the vertex, right?
Right.
Yeah.
Yeah, I guess the mistake I keep doing is instead of just factoring out the coefficient from the first two terms, I factor out the coefficient from all the terms. And that kind of, I see, so you just factor out the first two terms to easily figure out the factoring.
Right. Yeah, if you factor out all three, then it'll that would mess you up.
Yeah. Okay. Got it.
Let's see. Want to see number 7, putting it in standard form?
Yes, please. And then I think that yeah.
The vertex formula is actually easier formula to use to get the vertex. The reason why some books will emphasize putting in the standard form is this is a very popular technique in calculus. So those going on will see this. Because in calculus you have your your integral, and then your goal down here is to put this in a form of like something squared minus something else squared. And you have to do the same technique where you have to add and subtract it right together to do it.
Okay.
Okay. Now this problem's a little bit easier because there is no number, there is no coefficient in front of our x squared. So we don't have to do step 1. We go down to step 2. Take the number before the x, which is the invisible 1. Multiply it times a half and squared. So that gives us 1/2 squared or 1/4.
Right.
And then we'll both add it and subtract it right in that same location.
Okay.
Now in this case,
No, 1/2, right? It's x plus 1/2, I guess.
yeah, x plus 1/2, exactly. Is when you factor that. And remember that trick just makes it so easy.
Yeah.
And that's 3/4. Yeah, whatever number's right here, right before you square it, sign included is always what goes right there.
That's cool. Okay.
Do you want to see number 8 too and 9?
Yeah, I'm gonna try to work those out, I guess, later. I don't know.
Okay.
Uh,
You were asking about page 238.
yeah, it's the maximum of you have like a box. You want to find the maximum volume. I wasn't really sure how to go about that.
Yeah, that threw me too until I looked at the solution. 'Cause I know how to do that with calculus, but then I wasn't sure how to do it with algebra, and then I read solution. It's like, oh, okay, yeah, I know what they want. So now you got your volume is equal to 4x to the third minus 44x squared plus 120x. So I'm going to plug that in, and the solution tells you to use the graphing calculator on it. So I'm going to go to my y equals. Actually, let me fix my calculator. I was recording some statistics earlier today and it's messed up. Okay. So I go to my y equals, and then I'll type in this 4x to the third minus 44x squared plus 120x. Now, this is kind of the tricky part. If you press graph, it's possible you might not be able to see the min or max. And it's wanting us to, in this problem, maximize it. And so if I look at the calculator, I see the low point here, but I don't see necessarily see a high point. But if I do a zoom and choose zoom out and press enter, at sometimes you lose track of the graph. And I'm not sure about this one because I haven't tried it. Let me try enter one more time. And see, we're not really seeing the high point or low point at that point once you've zoomed out twice. Now if I do zoom and I choose Z standard, put 6, that should set it back to your standard viewing window. And I'm trying to think, have you covered the leading coefficient in the book yet?
Which one?
The leading coefficient test?
No, I don't. I didn't see that.
Okay, then I won't use that. That's cheating for me to use it ahead of time. Let's see, if I don't know that, I suppose if I know the general shape of y is equal to x to the third. Generally, that looks like this. it's going down as it goes to the far left, and it's going up as it goes far to the right.
That's
Now,
what you from the limit, right?
exactly. Yeah. Now you could have some curves in here, but that's the general shape. So I know when this is going up, it's coming back down somewhere. Now, sometimes in the TA3, TA4, if you press zoom, there's a zoom fit, I think it is, at the end. Sometimes I have luck with it, sometimes not. Here's zoom fit. So let me choose that. Let's see what that gives. That kind of makes me think that this is where the max is. But let me see for sure. Now if I do a zoom and I choose zoom box, the first one, and then I do an up arrow, it's down there pretty good.
Well,
And left arrow, you eventually see a little plus, and I'll do an enter right there. You have to go up a little bit more. I'll press enter right there, and then I'll do a down arrow and right arrow, and it draws a box. And what this will do is it'll zoom in on the part you're drawing the box around.
Mm.
So hopefully that right there contains it. Let's see. Press enter. Yeah, see how that goes up and then goes back down? So the if I find this point right here, I can do my second trace, choose maximum, so I press 4. Now I want to go do my left arrow until I'm to the left of where I think the maximum is. It doesn't have to be too far away from it. You just need to make sure you're definitely to the left of it, like right there. Now press enter one time. It'll come up and ask me for right bound. And I'll press my right arrow key until I'm to the right of where I think the maximum is. And then I press enter. And for the guess, you just press enter on it. And that would tell us that our maximum occurs at 1.8. Now this is all based upon whether I actually could zoom and find the correct spot. Let's compare that against the books. Yeah. Oh, there's end behavior. Yeah, see, the end behavior tells me whether it's, yeah, the limit. Did I go by it?
I think it's right after the example.
Oh, here it is. Depth of 8.38.
Okay, yeah, 1.81, 96
Okay.
points.
Yeah, but that's how you'd get in the calculator.
Is there any way to like solve it without using a calculator, or you need to use some form of?
You got to use the calculator. Now,
Okay.
if we're in calculus, I'll say this because you said you took calculus before, right?
Correct.
We would find the derivative, which would give us 12x squared minus 88x
Right.
plus 120.
80x to the power of 2.
So this is finding a derivative, which you take the exponent and multiply it by the coefficient to get, which I forget. It's been,
Right. Take your power, put it out in front, lower it by 1.
Yeah,
Like this.
for the second one, you have to put minus 88 to x to the power of 2 because the second.
No, you lower
Oh
it
yeah,
by
you're
1.
right. You're right.
Yeah.
You're right. You're right. You know, I'm watching from the iPhone. That's why.
Oh. And then that gives us this. You set it equal to 0. And then you use quadratic formula, and you'll come up with 2 answers. And at that point, once you get those, then you can use your graph to help you figure out
okay.
which one's the correct answer. Right.
Yeah. Okay.
But yeah, you have to use calculus for that.
Okay.
Then you're asking about page 265, number 2930.
Yeah. Remainder theorem.
Okay.
I understand synthetic division is like awesome. I totally forgot about this, but it's like magic, you know?
Yeah, it's fun.
The thing that threw me though was when it's like a negative square root, and the other one is some like it's a longer equation than just like two parts.
I'm about to be really careful on that second one. I know I can do the first one just fine. 29. Well, famous last words. Let's see. So they tell us negative square root of 7. And then your largest power was x to the fourth. So you're going to have a place for x to the fourth, x to the third, x squared, x, and no x. Your constant term. And we got 1, 1, negative 6. 1, 1, negative 6, negative 7, negative 7. So we'll add, and then we'll multiply. Negative square root of 7 times 1 is negative square root of 7. And then you add 1 minus square root of 7. Now you multiply. So you take negative square root of 7 times 1 minus square root of 7, which negative square root of 7 times 1 is negative square root of 7. Negative times negative is positive, and square root of 7 times square root of 7 is 7.
Okay.
So this is 7 minus square root of 7. And then you add these, and you'd add together just the integers here.
1 minus root 7.
Right. Well, that's interesting. Same as that, isn't it?
Yeah.
Because this has to be 7 minus square root of 7. Negative 7 plus 7, they cancel each other, and that leaves me a negative square root of 7. And then that gives us a positive 7, which gives us a 0 here.
Wow, okay.
And, of course, I guess I should have read the directions. Determine P if it's equal to 0,
yeah.
factor it. Okay. So, this is saying that you got like x is equal to negative square root of 7.
Mm.
And if you take that over on the same side as the x, then it becomes x plus square root of 7 is equal to 0.
Right.
So then you're going to have x plus the square root of 7 times, and this is x to the fourth, this will always be 1 degree lower. So this is x to the third, this will be our x squared, x, and no x. So this will be x to the third plus 1 minus square root of 7 x squared plus 1 minus square root of 7x minus square root of 7. And that's how it'd be factored.
Okay.
Let's show the next one. 30. It's 2 minus square root of 3. And we have x squared. Oh, this one's probably easier. So we'll have an x squared, we'll have our x, and our no x, our constant term. And we got 1, negative 4, 1. Okay, so we'll add, and then you multiply. 2 minus square root of 3 times 1 gives us 2 minus square root of 3. Then we'll add together the integer. Negative 4 and 2 gives us negative 2 minus the square root of 3. Now, when I multiply 2 minus square root of 3 times negative 2 minus square root of 3, we got 2 items here and 2 items here. So we'll take 2 times negative 2. We'll take 2 times negative square root of 3. Negative square root of 3 times negative 2. And negative square root of 3 times negative square root of 3. Assuming I didn't mess up on signs. Okay. Which gives us negative 4 minus 2 square root of 3. And negative negative gives us a positive 2 square root of 3. Negative times negative is positive. Square root of 3 times square root of 3 is 3, which ends up giving us the negative 1. And then negative 1 and positive 1 gives us 0. Now to factor that, you have... Oh, sorry, go ahead.
Oh, yeah, no, that worked out really well.
Right, it did. Now we'll take this, and different books do this different ways. I haven't looked to see what this book does. But when you move this over, some books will keep it inside of parentheses, as in this form. So this would be x minus 2 minus square root of 3. And then this would be x squared plus negative 2 minus square root of 3x. Wait a minute.
Professor,
This
I think
is 1 degree lower. I'm screwing up. Yeah, that's x.
For the x equals 2 minus root 3, wouldn't it be x minus 2 plus root 3?
Well, actually, this would just, since this is now an x and this is our constant term, that should just be an x, and then would have a minus 2 minus square root of 3.
Yeah, but for the x equals 2 minus root 3, then you subtract 2 from both sides and you add root 3 to both sides, right?
You could do it
right.
that way.
It's the same thing.
Yeah, or some books will take the entire thing over, leaving it inside of parentheses with a minus in front.
Okay,
So,
I see.
I'm not sure what this one actually does. But yeah, that would be your factored form then.
I got it. All right, thanks, Professor. That helped a lot.
Good. Did you have any other questions?
I had one. This is like a really small question.
Okay.
For synthetic division, let's see, I'm not sure. It's the 3.2 homework, maybe number 30, 36, 37. I saw.
Oh, you were asking about the multiplicity. I didn't answer that question.
Oh yeah. I didn't understand what's the point of saying it's multiplicity 2 or multiplicity 3. It didn't really change my my approach.
Okay.
Does it matter? I mean, I know, or it's multiplicity 2, then I know that it's going to be like a parabola, right? Or it's going to be like a parabola.
Well, let's work number 37 and see it. You said number 37, right?
Yes.
Okay. And then I'll talk about just generally the benefits of the multiplicity. And I'll show it with an example. Okay, number 37. We have 4x to the 4th minus 28x to the 3rd plus 61x squared minus 42x plus 9. And it says c is equal to 1/2 is a 0 multiplicity 2. So it's a 0 and multiplicity of 2. What that means, when they tell you it's a 0, means we can go ahead and plug it into our synthetic division, because the goal here is to find the rest of the real zeros and factor it. So we can plug that in. And this is x to the 4th. So I'll add, multiply, 1/2 times 4 is 2. Add, that's negative 26. Multiply, 1/2 times negative 26 is negative 13. Add, 48. Multiply, 1/2 times 48 is 24. Add, negative 18.
Yep. Okay. Negative 18.
And then multiply, 1/2 times negative 18 is negative 9, and then add, and you get a 0. Now what this means is that when you get a zero's remainder, your factor theorem says that's one of your answers. It's a factor or a 0. So we found our first 0, which is not a surprise because they told us it was going to be a 0.
Okay.
Now, since we found that one answer, this went from x to the fourth, and we're now down to x to the third. When they tell you it's a multiplicity of 2, that means that you can plug in 1/2 again. It'll
Oh,
actually
you
work
keep going.
twice.
Oh, that's what I was wondering.
Yeah, and if they tell you multiplicity of 3, that means you can plug it in 3 times.
Oh.
Now you want to plug it in the line you just found. So add, multiply, add, multiply, add, multiply, add, and we get another 0, which means we found another answer, found another 0. Now at this point, each answer we find takes it down one more power. So this is now x squared, this is x, and this is our no x, our constant term.
Right.
So we can drop off, and we set that equal to 0. Well, the reason why you always set it equal to 0 is because you're finding zeros. Now I can factor out the GCF, which is 4, and I got x squared minus 6x plus 9. And then this will factor. This factors as x minus 3 times x minus 3. Now the zero factor property, zero product principle, I don't remember what this book calls it, but it says if you get 0 on one side and you factor the other side, you can set each factor equals 0. So I'll set x minus 3 equals 0. And it would say that I set this x minus 3 equal to 0, but it'll give us the same answer, won't it?
Right.
But this x equals 3, it's important to keep in mind that this has a multiplicity of 2, because it repeats.
Mm-hmm.
There's 2
Oh,
of
yeah.
them.
Mhm.
So really what we have is we have the x equals 1/2, x equals 1/2, x equals 3, and x equals 3. So for factoring purposes, if I were to take these and move them on the same side as the x, we would have x minus 1/2 equals 0. We'd have x minus 1/2 equal to 0, x minus 3 equals 0, x minus 3 equals 0. And so we'd have x minus 1/2 times x minus 1/2 times x minus 3 times x minus 3, or just simply this right here. And you will find that the multiplicity will connect directly with your power. So if I had a 4th power on here, my multiplicity would be 4.
Mm-hmm.
Now, in response to your question, well, what benefit is the multiplicity? I mean, that's nice that they give it to you, but what if you don't know what the multiplicity is? Let me show an example on that. Is that good on this one?
Yes, thank you.
Okay.
That one is times 4. The whole thing is times 4, right?
Oh, up here?
The down 2.
Oh, down here?
Yeah.
You could.
Oh, yeah.
It doesn't matter though. There's
Okay.
actually an infinite number of answers that'll give you this. Because, like you say, you can put a 4 here, 5, 6, and all of them will give you these same 4 answers.
Yeah.
Oh, let me clear that up. Of course, I'm always bad about actually reading the instructions. Instructions might have said what to do there. Now, this is a problem I use in my college algebra class I teach in the classroom. So we'll take a look at this one. It says graph this. So we got x to the 4th plus x to the 3rd minus 6x squared. And different things you can use. You can find the x-intercept. And to find the x-intercept, you plug 0 into the other variable. So I plug 0 in for y. And I get 0 is equal x to the 4th plus x to the 3rd minus 6x squared. Now I'll factor out a GCF of x squared, and that gives us x squared plus x minus 6. And then this factors as x plus 3 times x minus 2. Now the zero factor property says you get 0 on one side, you factor the other side, you set each factor equal to 0. So I'll set x equal to 0, I'll set x plus 3 equal to 0, and I'll set x minus 2 equal to 0. So we got 0, negative 3, and positive 2. Now if I were to put powers on these x plus 3 and x minus 2, they're the first power. That corresponds to our multiplicity. So this one has a multiplicity of 2, this one has a multiplicity of 1, and this one has a multiplicity of 1. Now what that tells us is whether it touches or crosses the x-axis.
Okay.
So if multiplicity is 2, that means it touches. And these means it crosses.
Okay.
And I won't go any further on that, just to point this out. Here's an x-intercept at 0. Here's one at negative 3, and here's one at positive 2. Now, I would know that it's going down as it goes to the left, and it's going up as it goes to the right. Wait a minute. This is x to the fourth. Let's try it again. Since this is a, we got a positive 1 here in an even power, then this is up to the left, and it's up to the right.
Right, it's like a parabola.
Exactly. And that's what the in the book where they're talking about. I think I saw it somewhere.
Maybe it's towards the, or was it the end conditions or something, or
Right. That's where it talks about that. And where that's beneficial then is if you know it's up to the left and up to the right, you know it touches here and crosses here, then I know generally my graph's going to come down, it's going to touch here, it's going to go up, at some point it will turn around, cross this, and then turn around and cross that.
okay, I see.
So you generally have the shape of the graph before you even need to look at the other techniques like your y-intercept and plotting a few points and so forth.
I get it. So it makes it quicker than doing like the testing a point to the left of the zeros or the right of the zeros to see if it's positive or negative. You already kind of know. But
Right. That right there just gives you a ton of information on just generally what it looks like. I don't know how far up it goes or how far down it goes, but I know it's going to follow that shape.
okay, oh, awesome. I get it.
What other questions did you have?
I had two kind of general questions. One, do you think I should download? Is that TA84? Is that open source? Can I download that, or is that something I'd have to purchase?
Are you talking about the Wabbit?
Yeah, maybe. Yeah, is that what it is?
Yeah, there's a emulator called Wabbit EMU. Some people install it on their PC, and some people install it on their Android phone. It doesn't work on iPhones.
Okay.
But what it looks like is looks like that.
Mm-hmm.
It's not bad. But it won't help you because if you go in for the proctored test, I think at the end, you can't take your computer with you. So, it'd probably be best to know how to do it by hand.
Okay. Well, there won't be any questions about like the finding maximum volume and stuff like that on the final. Will there? Or I mean, it'll be everything we can do from what we've learned.
It'll be from what we learned. I don't think there'll be any maximum volume in there because that would require you to. If they told everybody they had to buy a TA3, TA4 for the class, then they could put it on there. But otherwise, no.
Okay. Let's see what else. I think those are all my questions. Oh, do you have a lecture on chapter 3.4, the complex uh, complex numbers and fundamental role of algebra.
Yes, I put it out there. It's under the announcements. And I uploaded a video this morning about how to do it by hand.
Okay. Oh, awesome. All right.
So.
I'm gonna trying to read it. I got a little confused with the more recent chapters, but when I watched your videos, it was all very clear. Much more.
Okay, good.
Thank you, Professor, for meeting with us and taking.
Yeah, thank you.
Yeah, you're welcome. And I'm on here every Sunday, so I stay on here for 15 minutes. Nobody shows up, then I sign off. And but if you're gonna be late, just let me know, and I'll sign time back on.
Okay.
All right, great. Thanks again, Professor. We'll see you on the forum. We'll see you on the.
Okay. Well, have a good week.
I have one question. Is there any way how to write like the equations, right? You know, I'm having a hard time to write them on the keyboard. Like, is there like a program where I can write them and paste them?
Do you got Microsoft Word?
Microsoft Word. Okay.
If you got Microsoft Word, it has two ways of doing equations.
Mm-hmm.
One method is under the insert.
Okay.
If you choose object, and you should have object of some form no matter what version of Word you have.
Okay.
And then if you choose object, then you choose, you should have a Microsoft equation. That comes standard with every copy of Word. And then I could type in here, and then you choose that, and minus 7x plus 2 equals 0, and x equals, it'll do fractions. That's one method.
Okay.
And this is what I use a lot when I'm creating documents. And when you close that, then it puts it into your Word document.
Oh, okay.
That, and you could resize it or whatever. Now the second way I don't like very well, probably just because I haven't got used to it. But in the newer versions, I'm not even sure if I got a new version here. Oh, there it is. You can choose the insert equation.
Okay.
And then it's got the same type of deal here where you can choose this. And so if I want a fraction, I choose that, and I click up here. 3x plus 2. And there's probably nothing wrong with it. I'm just used to this right here.
Okay.
But those are two easy ways if you got Microsoft Word.
All right.
I think also if you're using Google Drive, you can get an add-on for typing in math. I think.
Oh, so I'll use that one. I think I'm gonna use Google. Yeah.
Yeah, I haven't played with that very much, but I think you're right because it has quite a bit of power. Not all the features of Word, but
it's nice. I mean, having things on the cloud is so much easier.
Right.
But thanks again, Professor. I'm going to sign out and